Hey there, guys. Welcome to the Talking Shite podcast, the inaugural episode of Talking Shite, the first ever one. This is the podcast where we invite guests on to talk about something they're interested in, and then maybe by doing so, it will interest you as well. My first guest today is Cody, my dog, also known as Trussler. Me and Trussler go way back. We were actually partners on a different podcast on Twitch. We were for a while, and it felt fitting to get him on my first solo project as the first episode. So, hi, Truss.
Do you want to come on my podcast and hold my hand for the first episode?
Yes, please.
I'm kidding on, man. I'm
Yeah.
glad that I'm honoured you asked me on for the first episode, to be honest, man. He's like, I'm going to do a podcast where it's all about the guest, man. It's all about what you want to talk about. I'm like, shit, I'm on the spot, man. I'm on the spot.
See, it works.
Bye.
It works for me because I don't need to think about topics. I learned my lesson from the Indie Scots podcast. I don't need to go and research gaming news every week.
That's it. That's it. Aye. Well, that's it, man. Fucking get a guest on it and do what we enjoyed. Take the bit we enjoyed about the Indie Scots podcast, ain't it? Pick a subject and just talk about it. Because that was one of the problems we had with it, was we had too many guests on. So I like this new format where it's just one person each week. Like I say, I'm honoured it was me. Thunder says hello as well.
Yeah. Hi, Thunder. Please put your lipstick away.
Right, not on the first episode. Come on.
So, Truss is known as Cody, my dog, on Twitch. You got a YouTube channel as well?
Aye.
On
Cody, my dog YouTube channel and the Indie Scots YouTube channel. Indie Scots YouTube channel is like, I'm just going to take it over as my own now. Use it as the clan YouTube channel, which it's always been. Do you know what I mean? It's where we put our highlights and stuff like that. So
you are a big Destiny player as well, aren't you?
I'd say I've been becoming less and less of a Destiny fan over time. But the thing that draws me into Destiny is one of the reasons we're talking about the James Webb today. Is the subject I picked was the James Webb, and one of the reasons I like Destiny is because that universe, like, I always see Destiny as something that like kids at university in that play. Do you know what I mean? It's and they can understand the lore. You're firing space magic at people, right? But there's also, like, my favourite gun in Destiny is a rocket launcher that most people in Destiny don't even remember, right? It's called Blue Shift, right? And that's one of the reasons James Webb's quite cool, because of the shift in light, right? And Blue Shift, if you imagine a slinky, imagine the light being a slinky, right? And the light being emitted from the star, that slinky then travels to you, and when it reaches you, the slinky's, think of that as the frequency. So you can see a waveform diagram?
Yeah.
Slinky, that's the frequency of light you're seeing, right? And if it's moving towards you, the slinky's getting smaller, so the things are getting closer together, and that's what's called blue shift, right? It'll look blue when it's coming towards you because the frequency's increasing, right? And the rocket launcher's called Blue Shift. It's arc, which means it fires a blue rocket and it fires right at your face. That's just beautiful naming, and it shows that the people making Destiny have a genuine understanding of the science that is required for space travel and looking out into space and stuff like that. And they've also got the Nemesis star, when people were talking about Planet 10. Like, I don't know if you've heard about how the planets of the solar system were discovered. We always knew about the inner planets, Mercury, Venus, Mars, and Jupiter. We always knew about that, and we always knew about Saturn, right? Because we could see them with the naked eye. But we couldn't see Uranus. And Uranus was discovered I can't remember who it was discovered by, but it was discovered in the early 18th century through telescopes, right? Somebody's seen it. They expected to see it there because of the way the maths worked for Saturn. They're like, wait, Saturn's nowhere we expect it to be. I think there's something else out there, right? And when they found Uranus, that's when they found Neptune as well, and that's how we found these planets. And Neptune's always looked a wee bit different. The maths has never quite worked right for Neptune. So we've always expected there to be something else, right? And that's where you've got quite a few well-notable scientists, Konstantin Batygin, Michael Brown, I think his name is, the two foremost scientists that work on that. But they're the ones searching for Planet 10, and they're just searching for it, maths and stuff like that, right? And they're the ones that found Sedna, and it's the furthest orbiting centaur that we've got. And do you know what a centaur is in solar terms?
Not in solar terms.
Well, you know what a centaur is in mythological terms?
Yes.
it's a half horse, half man thing. You move. Thunder, why are you so porn? Try to talk. But yes, a centaur in like this stellar or astronomical terms, right, is a planet-sized object that's kind of an asteroid and kind of a planet. So they call it a centaur. Do you know what I mean? So Pluto could be classed as a centaur, but the real centaurs are Ceres and Nessus is in Destiny as well. Do you know what I mean? So like that's why I like Destiny. But Destiny's been gone heavily commercial the past few years. But let's not talk about Destiny. We need to talk about James Webb and science and shit.
Well, was it Destiny that kicked off your love for space, or did you already have that?
No. I always enjoyed the stars because my grandfather, when I was growing up, used to do a lot of outdoor activities, go camping and stuff like that. He'd done the outdoor activities. There was a place called, I think it's still open, Kilbowie Outdoor Centre, and he worked there. And we used to go up in October week and he'd do the stuff that he would do with like the groups that would come up, he'd do that with his grandkids. And one of my favourite things was screw the canoe and screw the abseiling and all that. I liked the campfire at night time in a dark sky zone. In hindsight, I now know it was a dark sky zone. And he's going, that's that planet, that's that planet. That's Ceres, or Sirius, sorry, the dog star. That's the first, they reckon the very first temple on Earth was built to worship that star. And it's because Sirius has just appeared in the night sky. It's just starting to appear. And Sirius is the thing that says, yo, by the way, in 6 weeks' time, you'll be able to start planting crops. Do you know what I mean? And that was the thing that told the people in Egypt, yo, because that's why they've got dog heads in Egypt, because Sirius, the dog star. Do you know what I mean? Like, Sirius is the brightest star in the night sky. It's so cool to look at through a telescope. It's like, and one of the cool things about Sirius was only, 50, 60 years ago, they discovered that it was actually a binary star system. And that's why it twinkles. It's really quite cool how it twinkles. There's a binary star, and if the smaller star's in front of it is the light, remember I was talking to you about different wavelengths, light, blue,
Yes.
and blue and red. Well, as the light passes the smaller star, because the smaller star's spinning, and if the light's passing the left-hand side, say the star's spinning in this direction. So if the light's coming this way, right? Remember the planet's going this way. So if the light's going this way, it actually gets a very slight boost in speed, which means it arrives more, which means the slinky's more compressed. Right? And if it's going around the other side, it meets the opposing current of the planet's gravity. Right? Because remember, you've got centrifugal force with the gravity. And it's got that slight force where if it's coming around the other side, the slinky's actually extended. It's pulled a wee bit. And it flashes red and blue in the telescope. It's beautiful to look at through a telescope. I thought I could see the binary star the other night, but I just didn't have it. I was like, oh, this is well cool. This is well cool. Oh, I need to get it more focused. And it turns out that the telescope wasn't focused and there was a wee bit of dust on the lens. And it's like, Just, but you can't see it with, you need something big like something on the top. I can't remember what the telescope's called on the top of Mauna Kea. Or that new theory.
Is that the one on top of Hawaii's mountain?
Mauna Kea. Yeah, Mauna Kea is the mountain. I can't remember the telescope's name. You need something like that to be able to see the small star, the binary system and stuff like that. But Orion's belt's just come out, so it's good. It's good for me this time of year. I really like this time of year.
Yeah, that's really cool. I didn't realize that that star was the one that signified the 6 weeks till you can grow your crops. That's really cool.
I don't know if it's exactly 6 weeks, but I'm just saying
roughly,
that. You know what I mean?
Roughly that
It's
kind
roughly,
of. That is really cool actually. And obviously you just mentioned your telescope as well. What you've got quite a good telescope, isn't it?
It's in telescope terms, it's quite crappy, but do you know what I mean? But it's an entry level telescope, and I got a good entry level telescope. It's only got a focal length of 1320 nanometers or something, but it allows you to get the furthest away type of zoom I've got is 34 times, which lets you see the moon, right? And it lets you see the moon really, really cool. I could find a couple of pictures, I'm sure they're on my Facebook. But it lets you see the moon, the whole moon. And then I've got another lens, which is 4 times closer than that. So 34 times 4 is 120. It's like 134 and a half times zoom, right? And that one lets you zoom in on a quadrant of the moon. Do you know what I mean? So it really lets you zoom in. And then I got a thing called a Barlow, And what the bar load does is it doubles the focal length of your telescope, or you get a bar load times, like you get a 1.5 or a 2.5, and I got a times 2, right? So it doubles the focal length of your telescope. So what that means is when you put the eye lens in, you're like 1320 nanometers, and your eye lens, the small eye lens is 25 mil, right? So you do 1325 divided by 25 mil, whatever that is, that's your zoom, and it works out to be 24 or 25, right? And but once you insert the Barlow in, you have to times the 1320 length of the telescope by 2, which gives you 2640, and then you put the 25 mil in that, and then you divide that, which works out at 50 times zoom. Do you know what I mean? So we're at
So
Barlow,
glad you
the
told me
Barlow-
the answer. I hope you weren't going to go which equals, and I was going to be like, the fitness gram pacer test is like, oh, that was a lot of maths.
That's where the like it's so much easier. See when you're like explaining the maths. I always explain the maths, right? But see if you were here and I could show you the telescope, I'd be like, look, right, that's 25 times zoom. Boom, Barlow goes in, that gets doubled, blah blah blah. And you'd go, oh aye. And you'd look through the telescope and actually see it. Do you know what I mean? But oh man, it's so cool, and that's like I'd love to get a shot of one of the big telescopes, but I'm not a scientist, and I
Aye.
didn't do well enough in school, and it's not that I didn't do well enough in school. Do you know what I mean? I'm a Sparky trade. I done all right, but I didn't do well enough in English, so it'd be hard to get into uni, and I couldn't really go do what I wanted to do. So I'm
Okay.
just left being what's called a citizen scientist, and there's quite a few of them.
Okay. Now, and your telescope works through just normal lenses like a camera, so it
Yes,
takes in light.
it's an optical telescope. Yes, it's not a digital telescope. Yes,
So
you
is that
can't
with
connect a
mirrors?
camera to it. Yes, it's a mirror telescope. Yeah.
Yeah, and then going up, of course, your telescope compared to what we're talking about, the James Webb telescope.
James Webb's a completely different type of telescope, though.
Does that not work in mirrors as well? I know
Yes,
the
it's
Hubble
mirrors,
worked with mirrors,
but it's not optical. James Webb's only infrared. That's why they're putting it where they're putting it. Like, do you know what Lagrange points are?
I do not, but I've got a note here.
Quickly Google Lagrange points, and it's basically you've got the Earth, right, and round about the Earth, round about each celestial body, there's 4 points, 4 stable points, right? L1, L2, L3, L4, and I'm sure L1 for us is on the opposite side of the sun. Basically, it's Earth's shadow, where it is the opposite point in the orbit, right? And L2 is behind Earth, just behind it. And L3 and L4 are just before us and just after us in our orbit. And James Webb's going to L2 point. And the reason it's going there is so as it can sit in the Earth's shadow. And then it's got its sun sail as well, and it cools it down. Like on one side of James Webb's like something like 50 degrees Celsius, right? And then on the other side of James Webb, it's like minus 300. It's like crazy differences, and that's what it's all about. It's like cryogenic temperatures, and it's so as they can see. Remember, I was telling you about the slinky?
Yeah.
Well, we've got the observable universe, right? And they say the observable universe is 13.8 billion light years or something, right? And that's how far light's travelled, right? But there'll be light that we can't see that'll be further away. And it's because we're not looking in the infrared. It's only visible light we've been able to see so far. So with James Webb, the cooler we go, the more the most of the stretched slinkies that we can't see will become visible, and the visible universe will actually extend, because if we see these extended slinkies, they're going to be further away, and that's why we couldn't see them, because the universe is expanding. So with James Webb, we're actually going to be able to see beyond the expansion of the universe, which is fucking cool. Do you know what I mean? Like there's so many cool things about James Webb. Like the science it's going to do it is going to be excellent. The science it took to do it has already been excellent. Do you know what I mean? Like I was telling you before we started, the development for this began in 1996, and it had an 11-year schedule, and it was going to launch in 2007, and it launched on Christmas Day 2021. Do you know what I mean?
Did they
That's
announce
how long
that,
it
or
took.
did you just find out randomly one day, like, hey, Truss, happy Christmas, have James Webb?
They announced it about a week before Christmas or 2 weeks before Christmas that they were going to launch it on Christmas Day.
But you
Because they
lost
just,
your collective shit.
oh man, it just like that night it was cloudy. Do you know what I mean? You're like, oh yes, yes, yes. Man, it's fucking cloudy. Do you know what I mean? But it makes you want to get the telescope out and like, mate. Sometimes like just looking at it through a telescope can be boring. It can be if you've no ignited that fire in your mind with the questions.
Mm-hmm.
Do you know what I mean? If you're just sitting there looking for a telescope, sometimes you can go, aye, there, that's quite nice. Not seen that before. Do you know what I mean? Like, I seen Andromeda a couple of months ago, November time. Seen Andromeda galaxies through my telescope. Just a wee smudge, man. My telescope's not really that good to get it clear and that, but seen Andromeda galaxy. Do you know what I mean? Like, I've seen the Seven Sisters, the Pleiades. That's the one that sits right in the middle of Orion's belt that you can't actually see with the naked eye. Do you know what I mean? So the telescope, it lets you see things, man.
Mm.
And things like James Webb and that, like them getting announced, it makes you interested. Do you know what I mean? I'm going to have a wee look at that. Like, Beetlejuice is going mental. It's been fluctuating, and we don't know if it's there's dust in front of it or it's actually fluctuating, because we know Beetlejuice is ready to blow up. But what they mean by that is Beetlejuice might blow up in 1 million years. It might blow up in 5 million years. But to a star, that's nothing. Do you know what I mean? And that's what they mean, it's ready to blow up. And we might be wrong, it might blow up tomorrow. Like, like this year, we're expecting to see what's called a red nova. And it's when two stars collide. And it's going to be up next to, it's going to be in the Pisces constellation. And we're going to be able to see it with your naked eye. You're going to be able to look up. Like, people in...
I can't wait for that, because you know what's going to happen. You're going to have some people on the internet going like, this is the end. We're all going to die. Don't get vaccinated. Like, just so much is good. So much spraff is going to be spread on the internet. There we go. So much shite. Guarantee you. Give it a year and a bit, and somebody will be on Talking Shite talking about how the world's going to end because there's a big red ball in the sky.
Some cunt will be like that. See, it's a flat disc. When they explode, it makes a flat disc. Flatness. No, but we're literally going to see this red nova at some point this year, and it's going to be well cool. And people are going to be able to just look at it and go, oh, that's cool. But by I say a red nova, it's not going to be a supernova. It's going to just be when two stars collide, two medium stars. I think it's like a star the size of our sun and a star a wee bit smaller than our sun, going to collide, bam, they blow up. Might make a wee white dwarf or something like that.
So what's the difference between a supernova and a red nova then?
A red nova can be a supernova, but a supernova is usually, the red nova and the supernova are terms that define the elevation of the nova, and the nova is defined as a stellar explosion, right? That's nova. That's why nova bomb in Destiny, right? Stellar explosion. That's why that works, right? And the red nova just explains it's going to be a red explosion. Right, and it's not going to be that big. The supernova means it's bigger. Now, you can get a supernova with two colliding stars. They just need to be big enough, right? But 9 times out of 10, a supernova is because of the pressure in the star. Like our sun, take our sun for instance. Our sun is currently burning hydrogen atoms and combining hydrogen atoms together to make helium, right? Mm. And that's what releases the energy. Right? Once it's run out of hydrogen, it'll start burning helium. And we know, we teach it to our kids in primary school. Well, I definitely taught it to my nieces and nephews when they were in primary school, that the sun in about 5 billion years is going to balloon because it's going to run out of hydrogen. It's going to become a red supergiant like Beetlejuice and burn helium for hundreds of millions of years, right? But when it becomes a red giant, it'll be about the size of the orbit of Mars. And Earth will not be there anymore. We know Earth's going to die at one point because of a star, right? But our sun will never be a supernova. It's just not big enough. Our sun will keep doing that, and our sun will actually just become a nebula because it's not got enough gravity. The nuclear fusion's pushing it out too much, and there's not enough gravity to hold it in, right? And our sun will just, and the outer layers will just come off and be a nebula, and there'll be a wee white dwarf in the middle, right? They pretty much know that. That's going to happen to our sun.
And nebulas are those really cool gas clouds we see, isn't it?
They're the gas clouds that condense in and make stars. Yes. So a
Oh
nebula
yeah,
becomes
Is
a
it they
star.
say the star nurseries and stuff? Is that it?
Star nurseries are in nebulas, yeah. So that's what's going to happen with our sun. Our sun's going to just and become a small nebula, right? A dwarf nebula or whatever. But you can get bigger stars, and the opposite thing happens. See how our star had too much nuclear force, not enough gravity? The opposite happens, right? Like suns keep burning, and they burn helium, and they keep burning all the way up, helium into oxygen, blah, 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 all the higher elements. And then they eventually make iron, which they store in their core. And you can't fuse iron into iron to make anything denser. Right? You just can't do it unless you've got massive, massive pressure, which there isn't when any star in the sky just burns, right? But that's where a supernova comes in. See, the more iron it creates, the denser the core, means the more core the gravity's got. And the more that defeats the nuclear force, it actually pulls it in on itself. And when it pulls it in on itself, it crushes it, and the pressure with the nuclear force increases to the point where it just goes mental and it explodes. Boom. And that's where, see all your gold, see everything above iron, every metal above iron. That's where it was all created in a supernova. If you're wearing any gold on your fingers, that was really cool telling my niece that when she was 7. So this gold ring that my mum bought me came from a star exploding billions of years ago? Aye.
Yeah,
Mate, it's so fun telling.
It's like magic. It's like magic to them. Like they can't like. Well, I guess we can't.
Supernova is.
Yeah,
and you
definitely.
get different. You obviously get different sizes of supernovas. You get hypernovas and stuff like that. But that's why black holes are so weird to people. Do you know what I mean? But like, I'm no scientist, like I said. But me, to be honest, I think black holes are simply just. See, like I was talking about, you get bigger and bigger stars, and then you get bigger. Well, you see, eventually when a star becomes so big, it becomes what you call a pulsar or a magnetar, and that's with telescopes and that. That's the densest stars we can see, right? We use pulsars, 7 pulsars. If you get 7 pulsars, that's how you write a star map. Right? You need 7 points, right? And basically a pulsar, there's loads of pulsars that we can't see, because at the north and south pole of the pulsar, they're releasing light beams constantly, massively high energy, right? And they do this for billions of years because they've got so much energy. They're so condensed. They say that if you take a teaspoon of pulsar material, it'd weigh the same as the Earth, right? So that's how dense these things are. And the light coming out the top of them, they spin so quickly as well, they spin at all different rates. And if the north or south pole is pointing at us, it'll flash at a specific rate. Like quartz in the watches. That's why we can trust our watch so much. Pulsars are actually more accurate than the quartz we use in our watches to keep time, right? So that's how we use the ones that are pointing at us. So 7 of them, and you can go, right, I know where I am in space, right? And they're the densest ones that we can see with our eyes. Me personally, I just think black holes are, because we know that 2 pulsars together make a black hole. Now, if a pulsar was bending light at almost a 90 or 110 degree angle when it goes past it, do you know what I mean? And sending light off in all different directions, then if it gets a wee bit denser, surely it's going to bend light more. And a black hole is simply a star that bends all light in 180 degrees back on itself. That, to me, explains a black hole, but everybody wants them to be these special things. They want them to be a gateway to another universe. Do you know what I mean? Oh, it's the portals between us and the multiverse. Like, no, it's no. If I can explain it and make it make sense like that, do you know what I mean? Like, but to be fair, they are the only things in the universe that act that way, that bend light to such a degree where we call them holes. Do you know what I mean? But like, Another thing to back up my theory, they're just a star. Every star that we know has stuff orbiting it. It doesn't matter how much stuff it's got stuff orbiting it. Even if this tiny little star went past this big massive star with its solar system and this solar system, when it goes through here, the big star's going to gobble up most of this wee star solar system, and it's going to leave and be like, wait, where's Jimmy and Bob? Do you know what I mean? And it's going to be floating about the galaxy with less planets, but it's still going to have stuff running about it. Do you know what I mean? So, like, galaxies are just the stars that kicked all the wee planets' his ass. Do you know what I mean? And just became ate the big stars and ate the big stars. Because we're talking what they say the universe is 13.8 billion years. Of course, there's plenty of time for that to have happened.
Mm.
Do you know what I mean?
Yeah, especially
like,
at the speeds that everything's going at as well. Like, obviously, the universe is, well, the knowable universe is so big that the number isn't even conceivable by our brains. But
that's why I don't mention numbers when I'm talking about star sizes. You notice I didn't mention a single number because that's what puts people off astronomy. Is everybody's constantly talking about numbers. And fair amount if I was talking about numbers with my telescope, but that's so you can understand the telescope. That's the only numbers I'll talk about.
Yeah.
Do you know what I mean? Because you talk about numbers when you're talking about your telescope, and like I was saying, it's much better when people are there, and that's the reason I do it. Because I'm usually explaining it when somebody's there. Because you're explaining the numbers, and then they look through the telescope, and then they go. And they're asking, what was the numbers again? Because they can actually see that. And you go, stay it on your phone real quick, and you tell them the numbers, they do it on their phone. They're like, oh, aye. Do you know what I mean? Like, see the ones that instant gratification. It's like old video games. Do you know what I mean? Like, seeing that wee cubby hole, there used to be something good, nice, and rewarding to reward you. Do you know what I mean? It's like, that's the way it's best to have to tell people something. Like, there's no point in talking about the size of a star using mass. Do you know what I mean? Just use they're like elementary school physics. 1 + 1 = 2. 2 + 2 = 4. 4 + 4 = 8. 8 + 8 = a black hole. Do you know what I mean? And that's pretty much my theory of fucking the evolution of stars. And that's
I really
what I
hope,
teach
like,
my nieces and nephews.
I really hope that there's someone listening to this podcast and they've got a kid in the back seat of their car or like in somewhere, and then they go to school and they say, "Oh, what's 8 + 8? It's a black hole." That would be fantastic.
Oh, man.
To talk a little bit about numbers, though, I've just had a quick look at stuff just so people can idea. Again, going back to the James Webb Telescope we're talking about. So right now it has been launched. Like I said, launched on Christmas 2021. Today, as of
Christmas present.
Yeah,
in at least a decade.
Yeah. And all of as of recording this is the 31st of January 2022. I remember we spoke about a bit before the podcast about the testing that still needs to be done. There's still a lot of testing that needs to be done.
Oh, there's still a lot of calibration that needs to be done, mate. Yeah, man. I mean, because that's why I was talking about the James Webb is so cool, because it's this massive telescope that they fit into this tiny wee point. What was the points of failure? There was 344 single points of failure. So that means there's 344 places that could have went wrong when it was all unveiling and stuff like that.
Mm-hmm.
Do you know what I mean? And it never missed wiring. They said it was only going to be operational for 10 years because of the fuel it has to use. It doesn't actually sit at L2, it orbits L2. Right? So it orbits the Lagrange point. So every now and again, it's got to use a wee bit of fuel to keep its orbit, right? And they originally estimated 10 years because it was obviously an overestimation, right? Or an underestimation, right? And they announced like a week ago, James Webb's going to have fuel for 20 years worth of science. No, the 10 that was announced. So it's up there for double the length of time. So that's really good. Do you know what I mean?
Is fuel the main reason why we need to keep updating these telescopes? Not just for scientific purposes to look at different things, but also because they run out of fuel.
What do you mean?
Isn't like are we not going to be able to go up and refuel it? Or
no, we can't. Once James Webb set up, but it's too far away. It's over 1 million miles away from Earth. It's too far away.
I googled it. It said it was unless I've missed a zero, because I actually got 91,000 miles. I was like, that's not a lot.
It's 1 million. It's 910,000 miles in, isn't it? It's a fuck ton away from the Earth.
I'm gonna have another quick look to see if I can find. Oh, Webb will orbit the sun. Or no, Webb will orbit the sun. What?
It orbits the sun. It orbits the sun.
Oh, it's because we're orbiting the sun.
Yes. It's not orbiting us. It orbits the sun with us. It stays behind us at all times with the sun between us as it goes around it.
Okay.
So it's technically orbiting the sun.
Yeah, Webb will orbit the sun 1.5 million kilometers, 1 million miles away from Earth. A couple of other numbers I've got is it's currently going at a speed of what they said was 6 miles a minute. To put that into number is a bit easier. That's 580 kilometers per hour, which is a bit faster than the national speed limit.
Aye.
And I hope it gets a ticket for that. That's outrageous behaviour. But aye, going on to a bit about the telescope itself, just in case
I
people
remember I was talking about the focal length of my telescope is 1320 nanometers.
Yeah, this thing's probably good. This is
James Webb is 131.4 meters.
So
that's crazy, man.
So this telescope, obviously, because like comparing it to something like the Hubble, where the Hubble worked with mirrors, and the mirror that the Hubble had was about
the Hubble telescope. The reason it was named after Edwin Hubble, and he was the guy that basically figured out that thing about the slinkies I was talking about. He was the one that noticed. He was the one. See, we now know that the universe is expanding uniformly in all directions. That was down to Hubble, because he was the one that noticed. By the way, see, any direction you look, all the galaxies look red. They're all red shifted, which means they're all moving away face. All the slinkies are getting longer, but there's one galaxy, and that's why that's why people make such a big deal about it. And it's Andromeda Galaxy's blue shifted, which means we're
coming closer to Andromeda.
They say the process of the merger's already started, but what is it they call it? It's like something filament. I can't remember, but we're part of a massive. Like the Milky Way, it's part of a massive galactic supercluster that's all gone in one direction towards what they call the Great Attractor. It's quite cool. There's like...
Wait, so they think there's something out there that's attracting all these?
Yeah, man. They like in our local zone, and like maybe about 1 million light years across. Maybe no.
And we're talking the Milky Way. We're not just talking where we are. We're not the Milky Way. We're talking about our galaxy.
Imagine the universe, our section of the universe, where like maybe the next 500,000 galaxies or something. I can't remember what it's called, but it's the theories about the Great Attractor. And basically, like, Milky Way is one of the smallest ones. We are like infinitesimally tiny compared to some of these galaxies, man, and they're all getting ripped in that same direction. And we don't know what it is.
That's fucking terrifying.
Aye, the Great Attractor's pretty terrifying. Aye.
Oh,
space is fucking like if you want to think about it, and if you want to be scared, you'll be scared when you're thinking about space and the possibilities.
Wait, I get freaked out when I look at the moon, just thinking, wait, that's in space, like that's another thing.
Aye, the theory of the Great Attractor, we're all going in one direction.
God, how long is it going to be before people start worshipping the Great Attractor?
I don't know, just Google it.
Whilst he's Googling that, I'll give you some quick numbers and stuff. So if you want to know a bit more about the James Webb as it is, currently it's about the sun shield, that's not its propulsion system. That's just protected from the sun, isn't it? Literally is what it is,
yes.
Is a sun shield.
Yes, yeah. The sun shield. Yeah.
So the sun shield itself is roughly 70 foot long, which is about 8 foot shorter than a tennis court, and about 47 feet wide, which is a bit wider than a tennis court. So there's a kind of a bit of a look into it as well. The mirror itself, and this is why we're talking about Hubble as well, the Hubble mirror was only 2.4 meters in diameter, whereas the Webb is apparently 6.5 meters. And it's interesting as well, because the Hubble mirror... huge. Yeah, the Hubble mirror was a circle. A circle with a smaller circle pierced out in the middle. But is that what the light travelled through?
Yeah, bounced in and back.
Yeah, whereas the James Webb mirror is made up of loads of different hexagons. The mirror itself is more of like a hexagon made out of hexagons.
Aye, it's a hexagonal grid. Aye. Because the reason they made it like that is because it had to fold up. It couldn't just be sent up in one piece, whereas Hubble's mirror was sent up in one piece.
Because Hubble's a lot closer, isn't it?
Hubble just orbits Earth, aye.
Yeah, so hoping this. What is it they're exactly wanting to find with the Webb? Because they'll obviously have a goal, like its mission.
James Webb's mission is to see beyond and see the dark spots of the universe where you can't see it. To see what's in there.
Yeah. For those wondering, listening, I want you to
So, no,
now
just find
picture
it. I'll just Google it.
a grown man with two arms extended, and this is how he explained it. Let's say just like he was like a field goalie in American football, just pointing in different directions, like he was doing ninjas dance on Twitch. Just it's got a point there and point there. But
Pretty much. It says, the goals of the James Webb. The James Webb Telescope is an infrared observatory that will complement and extend the discoveries of the Hubble Space Telescope with a longer wavelength coverage and greatly improved sensitivity. So it can take optical images. It's just.
Do you know when we're expected to get these pictures, like the first ones?
6 months.
6 months.
6 months worth of testing. But remember, they just announced another 10 years worth of lifetime that wasn't there before. Do you know what I mean? So they can take their fucking time for all I care. Just make sure it's make sure it's fucking good, boys. Do you know what I mean? Take your time.
Right.
But the Great Attractor is a gravitational anomaly in intergalactic space and the apparent central gravitational point of the Laniakea supercluster. The observed anomalies suggest a localized concentration of mass millions of times more massive than the Milky Way. So they reckon there's a huge, the biggest black hole we've no discovered yet. Probably out there, and it's just attracting everything towards it.
We're going to the party, basically.
Aye.
So here's a bit of a philosophical question for you then, if we're talking about this. With the James Webb, right? If you got control of it for a month, right? I'm saying a month because I'm guessing sending the signals, getting the pictures, then waiting for the pictures to come back takes a while. What would you want to find if you would want to find something, even if you didn't find it or not?
Exoplanets without a shadow of a doubt. Like there's already a few exoplanets where we've found where they've got Goldilocks zones and oxygen in the atmosphere. And fair enough, there's not a lot of it. Do you know what I mean? But I'd like to find these ones where we can start writing books about a planet that exists almost exactly the same as Earth. Do you know what I mean? Like Avatar's planet can become like, it's a fictional planet, but look, one exists. We've got pictures of it.
What was really interesting about what was really interesting about Avatar, like the James Cameron film, that his world is the fact that was a moon.
Because like one of the things, like you're talking about a philosophical question. One of the things I was talking about a couple of weeks ago with my mate was as human beings, as a human race, we've lost like see how people like the Vikings are villainized in history. The Vikings were the biggest part of history. The Vikings were the first to go here. The first to clash this culture with that culture and this culture and that culture and this and the next thing, right? They were the first to fucking do almost everything. And we've no got those explorers anymore. Can you imagine if the Vikings still were doing Viking-y stuff? Do you know what I mean? Like the new with space travel, mate, they'd have fucking stolen a rocket for SpaceX and they'd be living on Mars. Do you know what I mean? It's like this is my problem. Like we've no got people on the moon. We've only got the International Space Station. Do you know what I mean? That
should be shut down as well soon. I think that's
they've announced it's minimum 2024. It's staying up there too, though. Minimum 2024. I did hear that recently. But the philosophical thing, man, is that we need our explorers, and that's why that's what I want to find with James Webb is that planet that we can put there and go, by the way, it's only 35 light years away. And people are like, what does that mean? And you go, it means we have to build what's called a colony ship because we're not going to get warp drive. And we need to build what's called a colony ship. And it needs to be cool enough that people are willing to die on it. Do you know what I mean? Simple as that. Like people need to be willing to call it their home planet. As soon as they're on it, that's their home planet. It's all they'll ever know. And they need to generational ships, man. Like, and I think gene splicing's quite a cool thing as well. Like, think about this, right? We're talking about all these cool things like you see in science fiction and stuff like that. You see the stasis chambers, right? For instance, stasis chambers they're never going to be a thing. Do you know what I mean?
Mhm.
See all the people that have been cryogenically frozen. See when that company goes bankrupt in 50 years, the machines will get turned off. Do you know what I mean? And the people never like, but they're never going to see stasis, right? But we know that we can splice genes, so would it really be that hard? I mean, it's already proven that mammals are very alike. Do you know what I mean? Gene-wise, and viruses and that can jump between them. That's why we get COVID. That's why we. Do you know what I mean? These are all diseases that originate from animals. Do you know what I mean? Like, that's why when the Europeans went to America, we killed them all because we had all the diseases for our animals that they didn't have and stuff like that, right? But you've got, oh fuck, I lost my point on the sidetrack there.
Well, like with diseases, it's happened a lot as well. Like back in, oh god, there was something to do with like well, was it grey squirrels are a perfect example? Grey squirrels are not native to Europe or something, or they're not native to the UK.
I didn't know that.
No, sorry, no, they're not native to America.
There's
Yeah,
invasive things called invasive species, and they come in and they completely take over the ecosystem.
But yeah, here's the one. Do you think we'll find life with James Webb? I know that's a big question, but
I think it's possible we've already found life and we just don't know it. Do you know what I mean? Like, and like, it depends on what kind of life you're talking about. Do you know what I mean? Will we ever find a thing we can communicate with? Me personally, I don't ever think so. I think human beings are special. And I think, special in the way that we were chosen by God or whatever, right? I think we're special in the way that our planet is ridiculously lucky. Earth is so fucking lucky. Do you know what I mean? Like, most people haven't heard of the Boring Billion, right? And it was a period of Earth's history where nothing happened for 1 billion years. Life had already been. There's stuff in the ocean and that. And it all died. And the oceans rose and rose and rose and rose, and there was no ice. And because all the ocean was above the land, the volcanoes couldn't erupt in air, which means the carbon cycle couldn't happen in air, which meant the Earth was doing nothing. And life clinged onto the very bottom of the oceans. And then, I think it was the Chicxulub asteroid. See the Gulf of Mexico is a big crater. That asteroid was apparently a big icy comet that struck us, and when that happened, because it put so much stuff in the atmosphere, it caused an ice age because the sea levels to drop, and when we've only ever we need the ice up there. Do you know what I mean? We need our ice, and that's when life started, and that's what the Boring Billion is, and that's just one example of how lucky Earth got. Then there's the Theia example. You ever heard of Theia?
yeah, well, Thea there was another planet that we crashed into.
You see Theia almost every night, aye. Theia's what we now call Luna, we call it the moon. And apparently there was two planets, Earth and a Mars-sized planet in the same orbit, and we crashed into each other. And that's why we've got the axial tilt, because of the angle it hit us at. That's why we spin at the speed we spin it, because we've only ever been slowing down from that. Do you know what I mean? And that's why, because we were bigger, we got the more dense material and it got the lighter stuff. And that's another reason why we're so lucky. We've got the tides. Do you know what I mean? Like, we survived that explosion. There's so many different things that makes Earth incredibly lucky. Like, we've got Jupiter sitting there, the solar system's policeman, I tell my nieces and nephews. So does it make sense to him? He's like the policeman of the solar system. He just sits out there, basically sees all the asteroids away. You're not getting in. Solar system's bouncer. Do you know what I mean? Aye, man. Like, James Webb's going to be so cool. The things we're going to learn, the things people are going to teach me because of the James Webb, it's going to be awesome. Because, like I say, man, like, I've got a backyard telescope and a curiosity is the best way to do it, and that's it. Do you know what I mean? I like it, so therefore I'm interested and talk about it quite often. So I seem knowledgeable, which I suppose I'm on a wee bit, but I'm a knowledge leech. See, as soon as I know somebody's more smart, more intelligent than me, what's this? What's that? Any chance you could explain this to me? Do you know what I mean? Like, I would define myself as I'm a seeker of knowledge. I love to learn stuff. I just love to learn stuff. Great fun.
I know I asked, what you would want to find with James Webb, and I know this is probably a question that I don't understand the scale of, but if you could point it in a direction, do you know where you'd want to point it?
I'd want to point it in the direction Carl Sagan sent the Arecibo Message.
You honestly just come out with it. Like, I was asking that question, wondering if you're going to go, I don't know. You have a fucking answer. Oh my God, that's amazing.
Because, like, do you know what the Arecibo Message is?
Is that the one that's got, it's like...
It's the one that basically looks like Space Invaders, but it's a coded message, and he sent it, towards a single star system. A single encoded, directed message. And if there is somebody there, they're going to know we're here. So see with the James Webb, we need to find out if there is somebody there. And see if there is, we need to get fucking ready. So that's, do you know what I mean?
We need to find out if they're already on their way.
Because see when it comes to space battles, see whoever turns up at your front door, see the fact that they turned up at your front door means you're about to get an ass kicking. Mm-hmm. Because if they turned up at your front door, means they can go at speeds where a speck of dust would be bigger than the Tsar Bomba, the biggest nuclear explosion, bigger than the biggest meteor that's ever hit Earth, but more energy. Do you know what I mean? Like, their spaceships can survive that shit, and we're going to fire some machine guns and rockets at them. Are you kidding on?
Mm-hmm. We might as well just go, all right, well, we're already handcuffed.
Might as well do like fucking Cartman's cat does in the early South Park, man. Walks about showing its asshole. Meow.
This, oh God. There's so much that you can really talk about. Is it even just like the whole light spectrum thing? Like, I know I said, we were talking about like, if possible, of finding life. Like, for me personally, I'm excited at the fact that if we even find bacteria on another planet, because it gives.
Mate, they say there's a more than negligible chance, like maybe something like, I don't even know the percentages, but there's a good chance of life being on Europa. There's a good chance of something life being on Io. Maybe not so much Io because it's got a thin atmosphere. But
those
Europa,
are Jupiter's moons, aren't they?
Europa's a moon of Jupiter, yeah.
And Io is a moon of Saturn? I don't know. It's
Io's Jupiter. I think Europa. Europa's Jupiter as well.
Mm-hmm. Again, going back, like, I only know about these moons from Destiny. So.
But Europa is basically a world completely made out of water. Mm-hmm. And the reason it's solid is because it's so cold, right? And it's got what they call an ice shell. See, we've got our tectonic crusts. It's got exactly the same thing, except they've got tectonic crusts on the surface that works by ice and water, right? And because of Jupiter and the other moons, it gets, with the gravity of everything else, it gets squashed and expanded. And see if you sat and done that with a tennis ball would heat up. So they reckon very deep down in Io, where the heat's at the greatest, there could be bacterial life. Do you know what I mean? Because there's life at the bottom of our ocean that doesn't require photosynthesis. It just requires a heat source. A heat source and a source of nutrients, which there could be in Jupiter, because you look about Jupiter and you see all the different moons, and all the different moons comprised of pretty much the same stuff, just in different volumes. Do you know what I mean? So, like, they called it Panspermia, and Panspermia is the theory that life might have been seeded on this planet from somewhere else. Do you know what I mean? There was an asteroid that came from a far-off solar system that had bacteria on it, and it was dormant inside, deep in the asteroid's ice, and it was travelling through interstellar space and eventually hit the Earth, and it seeded us. That's called panspermia. But you can also talk about panspermia being, it might have been Mars that the bacteria originated on. An asteroid hits Mars, knocks off a bit of rock. That wee tiny bit of rock comes down and lands on Earth as a meteoroid. Earth is now seeded. Do you know what I mean? Like a fucking plant in a garden. Do you know what I mean? It could have been. Do you know what I mean? We don't know where life could come from.
Yeah.
And that's why a couple of years ago, did you hear about a Muamua?
No.
Muamua was quite cool. That was an interstellar asteroid. Something that doesn't originate in our solar system, come into our solar system, come round about the sun, and went, and we watched it the whole way. And I think there's another one called Borisov happening right now. So there's something happened somewhere out there in the galaxy, and we're travelling through this debris field, and that's why I can't remember what the mission is, but they sent a mission up about a year ago, and it's coming to fruition soon. and they're basically sending an impactor to an asteroid system. And there's a big asteroid and a wee asteroid that goes round about the big asteroid, and we're going to impact the wee asteroid to see how much we can move the whole system. And it's for stuff like that, in case, because we know the asteroids in our system, we know how Jupiter interacts, so we feel pretty safe inside our own system for threats. But things like Borisov and Oumuamua, what if something comes through and just goes, wah, bam, fucking straight into Earth, hits us in the face? Do you know what I mean? We need to, and that's what they're doing as well. I can't remember the mission name.
Mission, please don't hit us.
Aye.
Mission, we are shite bags.
Hold on, I'll try and find that.
But you going on to, was it the what would you call it? The Panspermia?
You're all, I can't remember. You've totally blocked the word. Dart is the name of it.
Dart.
Yes, Dart is the name of that mission to impact the asteroid. What does Dart stand for? I didn't actually tell you what Dart stands for. Sure.
But that's basically is it a...
That's the asteroid impactor one.
That's what's looking out for all the other shite about around us.
Yeah.
You know, just reading that as well, like, talk about, did we speak about Brian Cox earlier?
Don't speak about Brian Cox.
You don't like him?
No, I don't really like him.
Well, what's wrong with Brian Cox? What do you not like him for?
No, man, he's just everything just seems filtered, and it seems as if he's talking to. It seems as if he thinks he's talking to an idiot. I feel. Do you know what I mean? He's one of the ones that he never gives his audience credit. He always feels like he's got to. Oh, I need to talk about this. Oh, but that means I need to start at the beginning.
Yeah.
You feel it. Do you know what I mean? You feel that, and you're like, he's got to fake the enthusiasm of telling that exact same story. Oh, this is how stuff works. Blah 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 blah. Do you know what I mean? I don't know.
Yeah.
I've never really It's not that I dislike Brian Cox. That's probably a bad way of saying it. I dislike Brian Cox. I don't dislike Brian Cox. He's good at what he does, but I can't watch his stuff. Do you know what I mean? Because I'm almost bored. Do you know what I mean? Because I always feel like he's paddling about in the shallow end. Do you know what I mean?
That's interesting because, like, I have a different like experience with Brian Cox, because obviously we're a different age group. I'm in my early 20s. You're in your early 30s.
He reminds me of Neil Oliver.
Missed him. Don't think I'm
the guy that done Coast on fucking BBC. The guy that went round about the coast of Britain. That cunt. He reminds me of him. He's the same type of presenter. That's why I used to say that.
But like, the reason it's interesting is because Brian Cox was the whole reason I got into astrology and into science.
See, that's what I mean. I shouldn't say this. Like, guy's really good at what he does.
Well, maybe that's it, because really, like, I got into. I want to say it was Wonders of the Universe. I was like 9 years old. It came on the BBC, and I was like, "What the fuck?" Like that kind of just blew my mind. What was possible, and everything I learned about space from him. It was great, but I could totally understand why people might not like him now, because, like, I guess you grew up with like Carl Sagan and Neil deGrasse Tyson.
deGrasse Tyson, not so much. But Carl Sagan was my first. I can't remember the name of his series, but my uncle had it. I had it on VCR. Had the Carl Sagan series in VCR. I remember watching that as a kid. It's the one with the pale blue dot and all that. And I mean, the thing about made Carl Sagan so good was, I remember that series starting, and I remember him talking about the evolution of human beings and all the way down to his maw. He was talking about his maw for about 5 minutes. Do you know what I mean? But aye, Carl Sagan was my first introduction to it.
And going into more like astrology and stuff as well. Only because we're just.
I like the guys that pose more questions than give answers, though.
Yeah.
Do you know what I mean? Like, I think that's why I tend to steer away from Brian Cox, is because he's always giving you an answer. He's never asking you a question. Do you know what I mean? And I think that's where it stems from when I say he never respects his audience. He's always telling them something.
No, I totally get what you're saying. But that's like, God, we could keep going, but we are coming up to that hour mark. So I'm trying to think. Obviously, talk about telescopes, and one of the whole points of this podcast is hopefully through talking about this, we've inspired some of you guys watching. Maybe you're now interested in astrology yourself. You want to go. So for somebody who maybe just want to get started off in astrology, want to get more into stuff like the James Webb Telescope, Hubble, what would you suggest them going and doing? What would you?
I would say if you're interested in buying a telescope, don't buy a telescope just yet, right? Because you might, like I say, it can be boring. You might not know if you're into it or not, right? But what I would say is buy a nice set of binoculars. 40 or 50 quid, you'll get a nice set of binoculars that'll let you see the moon in a good bit of detail. It'll let you look at Jupiter and Saturn when they're out, and you'll see them bigger, and you'll be actually see. Do you know what I mean? You'll be able to see the outlines and stuff like that. And if you like that, obviously you need to find somewhere. So if you even just a wee stand or something, you can just lean the binoculars on when you're using them.
Tell you what, I've got this because I know binoculars have a.
They usually have the wee screw hole in the bottom of them.
I've got one of these.
See the mic stand?
This is a monopod. Literally, just a monopod. I use it if I'm going out and about taking photography because I find it easier than the separate tripod. But
and much is that to buy?
This one was given to me actually.
But they look fucking like what? 20 quid? 10 quid?
I'm saying 30 quid for a good one. It's got a little wrist strap, my one as well. I actually use it to close my door right now when my cat comes in.
But yeah. That's how I started my niece, because I got a telescope and I got her a set of binoculars. And that's what she used. She uses her binoculars and she sees things, and she comes down and she's like, Uncle Graeme, can we have a look at this through the telescope and stuff like that? And her dad bought her a telescope for Christmas, her own one, so she's fucking, she's away, man. Away she goes. Budding astronomer. But that's what I would say, is get yourself a nice set of, not a big expensive set, but actually just get yourself something that you can look at these things in a wee bit more detail and see if you want more detail, and just walk up that ladder. Do you know what I mean? You might be sitting in a year's time with a huge big fucking telescope. Trust me, remember you said yours is 1230 nanometers. Mine is fucking 300,000 nanometers.
God, I just imagine in the comment section there's going to be people comparing focal length, like my focal length is bigger than yours.
And so I'm building an observatory out my back garden. Mate, that is my dream though, man. Get a house with a back garden, get a nice big fucking telescope, and commission like an observatory. And you know me, I'm a spark, so I'll electrify the thing and it'll turn automatically. And do you know what I mean? It'll be like,
well, you go up on your roof, don't you?
I don't have a roof to go up on. I go to my balcony, and if I can, I'll take it up to the local back roads, because there's a nice wee dark spot. It's not a dark sky zone, but it is darker than normal.
That's one of the issues that we've got right now, though, is because the fact there is so much like light pollution in the cities that it's kind of harder for people to go out to places. Like, there's actually a place in Scotland.
We've built this, human beings have built this massively cool telescope in Hawaii. It's called the Thera Rubin Telescope. It's named after a pure heavy cool old woman that discovered fucking dark matter was a thing when she was when she was in her early 20s, and she was one of the first women scientists to make it in the field of astronomy and stuff like that. Telescopes getting named after. It's got to be one of the most powerful ground-based telescopes. And SpaceX's fucking Space Link thing happened, and it completely throws off the pictures because it's all fucking bright. SpaceX fucked up science for profit. So honestly, let's not even talk about how much a clown Elon Musk is. Let's just.
I mean, I could link the Indie Scots podcast. We were all gushing over. Was it their Skynet? Bringing 5G to the world. But
I know. But in hindsight, man, I'm a clown for doing that as well, I suppose. But Elon Musk is just a boy that wants to build fucking trains and can't admit it.
Anyway,
don't call it a train, because then it'll know me my invention.
Well, this in my opinion has probably been the best start to the Talking Shite podcast. This is exactly what I was hoping for it. We literally talk about a subject, we let it branch off. We've talked about not only telescopes, we've talked about science in general, chances of life, exoplanets, talked about destiny, because I've just dropped my monopod. This is exactly what I wanted for this, and this is hopefully what you'll get more of from this podcast. And obviously, I couldn't think of a better guest to bring on than my former co-host of the
Thank you very
Undiscussed
much.
Hospital podcast and good friend as well, Trussler, Corey, my dog. Do you want to give them your links before we sign off?
You can just put them down below, man. You can just put them down below.
You can find COD on Twitch and on YouTube. You'll probably find them bits and bobs out there. He's probably on an astrology forum as well that you'll bump into him somewhere. But Trust, thank you so much for coming on the podcast.
You're very welcome, dude. Thank you for having me.
If you want to find more of me, of course, you can find the YouTube channel that this is on. You find me on Twitch as well, where I also play different video games. And yeah, thank you so much for listening, watching, wherever you're consuming this, whether that's YouTube, Spotify, iTunes, wherever. Thank you so much for listening, guys. And we'll see you next week for Talking Shite.
Bye.
Goodbye.
Yeah, funnies.
We built this network.